Hello and welcome to Tech of the Day. Today we are going to talk about very interesting topic implementing authentication in Azure. In this module we will cover Microsoft Identity Platform, implement OAuth 2.0 authentication, implement managed identity, implement certificate based authentication and implement Azure multi-factor authentication. This topic is really interesting. We will talk about different type of authentication, and also I will demonstrate on Azure portal and also some snippet of .NET C# code which you can directly use. And if you want to have some examples, you have freely available open source not open source, but if examples are available on Azure, on GitHub with Azure samples, so you can easily find them. So let's get started. Topics I have already talked about: Microsoft Identity Platform, implement OAuth 2.0, implement managed identity, implement certificate based authentication, implement Azure multi-factor authentication. Microsoft Identity Platform. In this lesson, we will learn about Microsoft Identity Platform overview, application types in Azure Active Directory, Azure AD, application and service principal objects in Azure AD, permissions and consent in Azure AD. Identity as control plane. Your cloud identity connects you to a wide variety of enterprises services both within your organization and outside of your organization. Identities are new control plane, and securing them beyond just a password is a priority among many organizations. If an identity is stolen, the person or even the company is at risk for losing precious personal information and intellectual properties. This can have devastating financial implications that are difficult to recover. So you have an identity which can be used to authenticate your on-premises apps, your devices, your employees, your partners and customers, and your cloud apps. You doing everything with the same. So Microsoft Azure Active Directory, which solves all these problems, is a Microsoft cloud-based identity and access management service. Azure Active Directory creates and manages credentials that help enterprise users sign in and access both internal and external resources that are offered securely by your company or third-party companies. Azure Active Directory's geographically distributed architecture combines extensive monitoring, automated rerouting, failover, and recovery capabilities, which deliver company-wide availability and performance to customers. So, with single solution Azure Active Directory, you can authenticate your Microsoft Cloud applications, which are service offerings by Microsoft Cloud, your cloud SaaS applications, your on-premises applications, your Windows, your other devices such as Mac OS, iOS, Android. So Active Directory Authentication Library. After knowing what is Active Directory, Azure Active Directory, you come to the point with Azure Active Directory Authentication Library. Azure Active Directory has its own authentication library, which for the clients that needs to access the protected resources, Azure Active Directory provides the Active Directory Authentication Library ADAL. ADAL v1 enables application developers to authenticate users to cloud or on-premises Active Directory and obtain tokens for securing API calls. ADAL makes authentication easier for developers through features such as configurable token cache that stores access token and refresh tokens, automatic token refresh when an access token expires, and a refresh token is available. Support for asynchronous method calls. And so in resume, Azure AD obtains and manages tokens, caches token using configurable cache, refreshes token automatically when they expire, support asynchronous invocation, and it's available in multiple languages like C#, JavaScript, Java, Python, Objective-C, all. So to create an ADAL context, in authentication context using ADAL, first you need to initialize your app's authentication, which is ADAL's primary class. The authentication context is where you pass ADAL the coordinates uh, it needs to communicate with Azure Active Directory and tell it how to cache the tokens. So you create tenant, then authority. Simple authority becomes login.microsoftonline.com/tenant, which is this one. You might have ID as well. And create authentication context using Azure Active Directory authority. So you create this authority and type of cache, file cache or whatever you want. Then the basic principle behind ADAL is that whatever your app needs an access token, your app simply calls auth context.acquire token async, this one, and ADAL does the rest. So when your app requests a token by calling acquire token async, ADAL will attempt to return a token without asking the user for credentials. If ADAL determines that the user needs to sign in to get a token, it will display a login dialog, collect the user's credential, and return a token upon successful authentication. If ADAL is unable to return a token, if for any reason, it will throw exceptions, which are ADAL exceptions. So very simple. You have the client ID, you have redirect URL, and your resource ID. And then you say platform parameters, prompt behavior never. So parameter for acquiring the tokens, you say the behavior for the platform parameters, and then you acquire the token using these parameters. So you just say auth context, which we just acquired here, auth context dot acquire token async, because we always have auth context, authentication context. So, and we will need this auth context everywhere to do all the operations with the Azure resources and ADAL. So until recently, most developers have worked with ADAL, Azure AD v1.0 platform to authenticate work and school accounts provisioned by Azure Active Directory by requesting tokens from the Azure AD v1 endpoint by using ADAL, Azure portal for application registration and configuration, and Azure AD Graph API for programmatic application configuration. This example depicts the evolution of Azure Active Directory into Microsoft Identity Platform. So previously people were used to have Azure Active Directory only, and then Microsoft introduced also Microsoft Identity Platform. So before we used to have Azure Active Directory only, which used to authenticate using against only a work or a school accounts provisioned in Azure Active Directory. Now you can use Microsoft Identity Platform v2 to authenticate against organizational work and school accounts authenticate against personal accounts such as Microsoft account, authenticate against customer supplied identities such as LinkedIn, Facebook, and Google, which is again uh, covering everything. So before we were only bound to use Active Directory, and now we have other options with Microsoft Identity Platform. If you are wondering what is Active Directory, I hope all of you know. So, in simple definition, Active Directory is a directory service developed by Microsoft for Windows domain networks. It is included in most Windows Server operating systems as a set of processes and services. Initially, Active Directory was only in charge of centralized domain management. So, Active Directory is a Microsoft product that consists of several services that run on Windows Server to manage permissions and access to networked resources. Active Directory stores data as objects. An object is a single element such as user, group, application, or device, such as printer. So it's clear, right? Azure Active Directory is a kind of you can say phone book which contains information about your relatives phone number, name, and other information, same as it's a directory which contains information about users, its rights, permissions, access. That's all. So Microsoft Identity Platform. Mm, Microsoft Identity Platform is an evolution, as I said, of Azure Active Directory Developer Platform. It allows developers to build applications that log in users, get tokens to call APIs such as Microsoft Graph or API that developers have built. It consists of an authentication service, open source libraries, application registration and configuration through a developer portal and application API, full developer documentation, quick start samples, code samples, tutorials, how to guide, and other developer content can be found easily on internet. The Microsoft Identity Platform supports industry standards protocols such as Authorization, OAuth 2.0, and OpenID Connect. So, with Azure Active Directory v.1, you could authenticate using ADAL and your using your work school accounts only. But with Microsoft Identity Platform, you can authenticate using your personal accounts, your social or local accounts, and then you are authenticated, and simply you have the final token, access token. So you see the difference here. Azure Active Directory only allowed work or school accounts here, and with Microsoft Identity Platform, you have it's using MSAL, Microsoft Authentication Library, which which is which which can authenticate using all these available resources. So more wide approach. To have Microsoft Identity Platform overview, with Microsoft Identity Platform version 2.0, you can expand your reach um, to these users like work and school accounts, as I said already, Azure AD provisioned accounts, personal accounts such as Outlook.com, Hotmail.com, whatever. Your customers who bring their own email or social identity such as LinkedIn, Facebook, Google via Azure AD B2C offering. So you are fully covered with Microsoft Identity Platform. So and if it's an evolution of the Azure Active Directory, a full-feature identity platform that provides an authentication service, open source libraries, application registration and configuration, full developer documentation, code samples, all that you can find easily. Microsoft Authentication Library, such as ADAL, there is MSAL, Microsoft Authentication Library, which enables developers to acquire token from the Microsoft Identity Platform endpoints to access secured web APIs. These web APIs can be Microsoft Graph, other Microsoft APIs, third-party web APIs, or your own web API. MSAL is available for .NET, JavaScript, Android and iOS, which support many different application architectures and platforms. So basically, MSAL can obtain and manage tokens, caches tokens by using configurable cache, refreshes tokens automatically when they expire, supports asynchronous invocation, and it's available on multiple platforms such as .NET, JavaScript, Android, iOS. So same way to create authentication context by using MSAL, we need to use Microsoft Identity.client, which is a library that you can use to sign in users and request tokens that you can use to access APIs that are protected by Microsoft Identity Platform. Creating a client application instance which initializes MSAL and sets an authentication context for further requests. So for that you need to have tenant ID or tenant, client ID, and authority, which authority is simply nothing but login.microsoftonline.com/tenant. And to create MSAL context by using Azure Active Directory Authority, you create client app, public client application builder dot create client ID with authority Azure Cloud Instance dot Azure Public and tenant dot build. So it sounds a bit complicated, but it's nothing. Just using the Microsoft Identity Client library, which requires you to use public client application builder, which will create a client using the client ID, and then with authority you just saying what type of authority, Azure Cloud Instance or Azure Public, and the tenant, you pass the tenant, and then you build the client. So once you have the client app here, now you can acquire the tokens interactively using MSAL. To call protected web APIs, you need an access token for your app. When you request a token, you need to define a scope. The scope determines what data your app can access. MSAL supports the ability to interactively prompt the user for their credential to sign in and obtain a token by using those credentials. So you have you say the scopes, you say user.read or user.write, but you should have these scopes already provided with your identity, so be careful with the scopes. Then window interop helper, then you just say it's simply a window handle. Then you say client app, which we just created in this one, client app dot acquire token interactive with this scope with parent activity or window, which is window handle, and with prompt, and then select account execute async. So with this code you simply saying with prompt, and to which redirects you to select an account with which you want to log in. So this is really interactive way of acquiring token using MSAL. You could simply fix a mechanism with that mechanism you could acquire the token as well. So but here what you said is prompt select account, which will give you the options, available options for login. And then you say the type of handle, Windows Enter Helper. This is a handle for window handle. And then once you have the auth result, which will give you if it's a success or failure, and other results such as user scope and policy, then you can simply have auth results.access token. But you can also acquire token silently without using the interactive window. If the user had signed in the past, you can acquire the token silently. The ideal platform is to perform a silent request and fall back to interactive request. After your app has signed in a user and received tokens, MSAL exposes several pieces of information about the user, the user's environment, and the tokens issued. The access token property contains a token that is used to call protected web APIs in HTTP bearer request. Accounts, first or default if you have multiple accounts. Then acquire token silently, you just say client app acquire token silently with the scopes you said and account, and execute async, and then you can simply have the token. Here you had these properties set so that you can get the token with an interactive window, but here you can directly acquire the token without giving user the notification of the window if he has signed in already. Now as you have signed in, you need to have the user profile information about the user. After you have the access token, then you can call the web API. Your app will use the token as part of the HTTP bearer authorization header to construct an HTTP request and then execute the request. Here we are getting user's profile by using graph.microsoft.com/v1.0/me. So what you're doing, you simply adding the bearer token which we recently acquired, and then default request headers authorization, this auth header, and then we just make the request to this endpoint. So we're making endpoint to Microsoft Graph API to get the user's profile. And this is simple call like for other HTTP clients you do. It's a simple same call, nothing special. So Microsoft Graph Authentication Provider Library. Microsoft Graph Software Development Kit, its SDK, which are designed to simplify building high quality, efficient and resilient applications that access Microsoft Graph. SDKs, which include two components, a service library and a core library. The service library contains models and request builders that are generated from Microsoft Graph metadata to provide a rich, strongly typed and decodable experience when working with the many datasets available in Microsoft Graph. The core library provides a set of features that enhance working with all the Microsoft Graph services. The features include embedded support for retry handling, secure redirects, transparent authentication, and payload compression, which improve the quality of your application's interaction with Microsoft Graph. These features do not add complexity but gives you complete in control. The core library also provides support for common tasks such as paging through collections and creating batch requests. So you have this Microsoft SDK which you can use to perform all these operations using MSAL, Microsoft Graph, which is referred as Microsoft Graph Software Development Kit SDK, which is a wrapper on top of MSAL, and also it has Fluent API to issue requests to Microsoft Graph. So about Fluent is an API developed by Microsoft Azure to help you to do many operations. So it has some inbuilt functions that you can directly use to do all the operations related to Azure cloud. It's very easy that you can use directly in your projects. So now creating authentication provider. The authentication provider classes are special helper classes that implement most of the logic that is usually implemented manually by using MSAL. To use the Microsoft Graph SDK, you will need to create an authentication provider instance to use as parameter for Graph client. Here, you can use the same application builder class from MSAL to specify the properties of Microsoft SDK Graph. So here what you're doing is simply client ID, redirect URI and scope. Then you creating the client application by using the same public client application builder dot create with the client ID with the redirect URI and build. So you have the client application. Now you create authentication provider by passing the client application and the scope you have here, and you have the auth provider. So now this auth provider, which is a special helper class that implement most of the logic that usually implemented manually by using MSAL. So you have a helper class already. Sorry, it's kind of authentication provider, but it's a helper which we can use for other things later on. So these there are many. So authentication providers implement the code required to acquire a token using MSAL and handle a number of potential errors for cases such like incremental consent, expired passwords and conditional access, and then set of HTTP request authorization header. The table describes the set of provider available in the library. So here you see authorization code, which is the authorization code flow enables native and web apps to securely obtain tokens in the name of the user. Then you have client credential. The client credential flow enables service applications to run without user interaction on behalf of on behalf of flow is applicable when your application calls a service or web API, which in turns call the Microsoft Graph. So you simply say on behalf of what? On behalf of Microsoft Identity. Implicit provider. The implicit grant flow is used in browser-based applications, which can be code flow or whatever. Device code provider. The device code flow allows users sign in to a device by using another device that has a browser. Integrated window provider. The integrated windows flow provides a way for Windows computers to silently acquire access token when they are domain joined. Interactive provider. The interactive flow is used by mobile applications like Xamarin or UDP and desktop applications to call Microsoft Graph in the name of a user. Username password provider, which is username password provider, allows an application to sign in by a user by using their username and password. Use this flow when only you can not use any of the other OAuth flows. So you have these type of authentication providers. Generally we use authorization code, but for mobile applications you can use interactive provider also. So using device code provider, the device code flow allows user to sign in to a device by using another device. With this provider, you only need to provide a client ID and authority. In this context, the authority specifies the types of accounts that you can allow to make requests by using this token. In this example, we are allowing requests to any Azure AD organization on the Azure cloud platform. So we say client scope user.read, and we create the client application using public client application builder, create with client ID and with Azure Active Directory authority, which we have the same. Then we use this client application and scope to create device code provider, and then this authentication provider, which is a device code provider, and same in this example, which we created interactive authentication provider, and with using the same client application and scope. Same way, in this one we are creating device code provider authentication provider, which we talked just before this slide. The integrated Windows provider. Integrated Windows flow allows Windows computer to silently acquire an access token when they are domain joined. With this provider, you only need to provide a client ID and authority. In this context, the authority specifies the type of accounts you can allow to make requests using this token. In this example, we are only allowing requests to a specific Azure Active Directory organization on the Azure cloud. So what we say, we Azure with Azure Active Directory authority, Azure cloud instance, Azure US government. We are only allowing Azure US government in this client application. Then we pass this client application in scope, and integrated Windows authentication provider, which is a type of authentication provider. So if you notice here, nothing is changing. Same in this one, nothing is changing, just this initializer. Pretty simple. The Microsoft Graph Service Client. The Microsoft Graph Service Client simplifies making calls to Microsoft Graph. So you can use this single client instance for the lifetime of the application. So this code example here, which depicts how to create an instance of Microsoft Graph client with an authentication provider. The authentication provider will handle acquiring access token for the application. After the client is created, you can use the me property to make a request to associated endpoints. So here what you do, you just create the graph client using the authentication provider we just had here, depend what you want, and this using this authentication provider, then you can do whatever you want. But here we are just getting graph.me, then request get asyncs, which we getting the information about the user. Application types in Azure Active Directory. There are 5 primary applications scenarios supported by Azure Active Directory. First one is single page application. A user needs to sign into a single page application that is secured by Azure Active Directory. Then web browser to web application. A user needs to sign into a web application that is secured by Azure Active Directory. Native application to web API. A native application that runs on a phone, tablet or PC needs to authenticate a user to get resources from web API that is secured by Azure Active Directory. Web application to web API. A web application needs to get resources from a web API secured by Azure AD. Daemon on server or server application to web API. A daemon application or server application with no web user interface needs to get resources from a web API secured by Active Azure Directory. Azure Active Directory. So there are 5 scenarios where you can use Azure Active Directory. So you see here, if a native or mobile application needs to access a web API, if a SPA needs to access web API or web application, or daemon or device needs to access web API, and then web API needs to access web API, or web application needs to access web application. Application types in Azure Active Directory registration. Note that registering an application is a necessary step which involves telling Azure Active Directory that the application, including the URL where it's located, the URL to send replies after authentication, and the URI to identify the application. Azure AD needs to communicate with the application when handling sign-on or exchanging tokens. The information passed between Azure AD and the application, including application ID URI, the identifier for an application. This value is sent to Azure AD during authentication to indicate which application the caller wants a token for. Additionally, this value is included in the token so that the application knows it was the intended target. Reply URL or redirect URI. For a web API or web application, the reply URL is the location where Azure Active Directory will send the authentication response, including a token. If authentication was successful for a native application, the redirect URI is unique identifier to which Azure Active Directory will redirect the user agent in an OAuth 2.0 request. Application ID, the ID for the application which is generated by Azure AD when the application is registered. When requesting an authorization code or token, the application ID and keys are sent to Azure AD during authentication. And then there is key. The key is sent along with an application ID when authenticating to Azure AD to call web API. In addition, Azure AD needs to ensure that the application has the required permission to access your directory data, the other applications in your organization, and resources. So you need these 4 things, but you need to have extra rights to read, if you are allowed to read user information or not. There are 2 types of application types in Azure AD authentication scheme. You can have a multi-tenant application or single tenant application. There are also some additional consideration when developing a multi-tenant application instead of single tenant application. In particular, if you are making your application available to users in multiple directories, you need a mechanism to determine which tenant they are in. To accomplish this task, Azure AD provides a common authentication endpoint where any multi-tenant application can direct sign-in requests instead of a tenant-specific endpoint. This endpoint is simply login.microsoftonline.com/common for all the directories in Azure AD, whereas a tenant-specific endpoint might be login.microsoftonline.com/your tenant. So you have 2 types of authentication. Application and service principal objects in Azure AD. In Azure Active Directory, authentication and authorization scenarios and application can function in these roles. First one is client role, consuming a resource server role, exposing APIs to clients. Both client role and resource server role. And so an auth 2.0 authorization grant flow defines the conversation protocol which allows client resource to access, protect a resource data respectively. So in this example, First, there is a process of creating the application and service principal objects in the application's home tenant. Then second, when Contoso or Fabricam administrators complete consent, a service principal object is created in their company's Azure Active Directory tenant and assigned the permissions that the administrator granted. Also note that HR app could be configured designed to allow consent by user for individual use. Third, the consumer tenant of the HR application, Contoso and Fabricam, each have their own service principal object. Each represents their use of an instance of the application at runtime, governed by the permissions consented by the respective administrator. So you have, we'll talk about more in a practical demo when we'll do on portal about service principle. But that's the main concept. If you understand, please pause this and try to understand this flow. Permission, permissions and consent in Azure Active Directory. Azure Active Directory makes extensive use of permissions for both OAuth and OpenID Connect flows. When an app receives an access token from Azure AD, the access token will include claims that describes the permissions that the app has in respect to a particular resource. Permissions, also known as scopes, make authorization easy for resource because the resource only needs to check that token contains the appropriate permission for whichever API the app is calling. Point out that the application in Azure AD rely on consent to gain access to necessary resources of or APIs. Your app might need to know about different types of consents to be successful. If you are defining permissions, you will also need to understand how your users will gain access to your app or API. So you have two types of permissions, delegated and application. Effective permissions, delegated permissions and application permissions. Delegated permissions, the least privileged intersection of the delegated permissions and the permissions of the currently signed in user. Application permission, full level of privilege implied by the permission. And there are three types of consents. Static user consent. An app must have already specified all the permissions it needs in its configuration in Azure AD. Dynamic user consent, an app can request an additional set of permissions during OAuth 2.0 authorization flow specific to Azure AD v2 app model. And then there is admin consent, required when app needs high privilege permissions. So what are the best practices for consents and permissions in Azure AD? Client best practices are only request permissions that your app needs. So that's a condition everywhere actually. Only do what you need. Don't grant extra permissions. Choose between delegated and application permissions based on the scenario your app supports. So choose carefully. Always use delegated permissions if the call is being made on behalf of a user. You only use application permissions if the app is non-interactive. So let's say web APIs. When using app based on v2.0 endpoint, always set static permissions to the superset of dynamic permissions. Then resource API best practices. Resources that expose API should define permissions that are specific to the data or actions that they are protecting. Resources should explicitly define read and write permissions separately. Resources should mark any permissions that allow access to data across user boundaries as admin permission. Resources should follow the naming pattern subject dot permission and then type of modifier. Implement OAuth 2.0 authentication. In this lesson, we will cover authentication authorizing access to web application by OAuth 2.0 and OpenID Connect. Authorizing access to Azure AD web application by using OAuth 2.0 code grant flow, service to service call by using client credentials. Authorize access to web applications by using OpenID Connect. To understand this, explain that Connect is simply OpenID Connect is simply simple identity layer built on top of OAuth 2.0 protocol. OAuth 2.0 protocol defines mechanism to obtain and use access tokens to access protected resources, but it does not define standard methods to provide identity information. OpenID Connect implements authentication as an extension to the OAuth 2.0 authorization process. It provides information about the end user in the form of ID token that verifies the identity of the user and provides basic profile information about the user. A user running a browser sign in enters credential and consents to permission. Then the OAuth 2 authorized endpoint returns ID token and authorization code to the browser. The browser redirects to redirect URI, the web server. The web server validates ID token and sets a session cookie. The web server requests OAuth to bearer token from the OAuth 2 token endpoint and provides the authorization code. And then the OAuth 2 token endpoint returns an access token and refresh token. The web server calls the web API with token in the authorization header. The web API validates the token and the web API returns secure data to the web server. So it contains around 9 steps. When signing the user out of the application, it is not sufficient to clear your app's cookie or otherwise end the session with the user. Instead, it is also necessary to redirect the user to the end session endpoint for sign out. Otherwise, the user will be able to re-authenticate to the app without entering their credentials again, because they will have a valid single sign-on session with the Azure AD endpoint. To accomplish this, you can redirect the user to end session endpoint listed in the OpenID Connect metadata document. OpenID Connect describes a metadata document that contains most of the information required for an app to perform sign-in. This includes information such as URLs to use and location of the service public signing keys. The OpenID Connect metadata document is accessible as login.microsoft.online.com/tenant/.wellknown/OpenID configuration. When you redirect the user to end session endpoints, Azure Active Directory clears the user session from the browser. However, the user might still be signed into other applications that use Azure Active Directory for authentication. To enable those applications to sign out from the user simultaneously, Azure Active Directory sends an HTTP GET request to the registered logout URL. If all the applications that the user is currently signed into, application must respond to this request by clearing any session that identifies the user and returning a 200 response. If you wish to support single sign out in your application, you must implement such a logout URL in your application's code. So single sign-in is easy to understand, as you want to implement that your all the applications you can sign in with a single identity. But if you want all your applications to sign out, or related applications to sign out simultaneously when you sign out from one device, let's say you sign out from mobile, you want to send the notification to the application on your another device so that they can sign out, and it awaits Azure Active Directory awaits response 200 for that. Understanding the OAuth 2.0 implicit grant flow in Azure Active Directory. The OAuth 2.0 authorization code grant flow is authorization grant that uses two separate endpoints. The authorization endpoint is used for the user interaction phase, which results in authorization code. The token endpoint is then used by client for exchanging the code for an access token and then often a refresh token as well. Web applications are required to present their own application credentials to the endpoint so that the authorization server can authenticate the client. The OAuth 2.0 implicit grant is variant of the of other authorization grants. It allows a client to obtain an access token and ID token when using OpenID Connect directly from the authorization endpoint without contacting the token endpoint or authenticating the client. This variant was designed for JavaScript based applications running in a web browser. In the original OAuth 2.0 specification, tokens are returned in a URI fragment that makes the token bit available to the JavaScript code in the client, but it guarantees that they won't be included in redirects towards the server. Returning tokens via web browser redirects directly from the authorization endpoint. It also has the advantage of eliminating any requirements for cross-origin calls, which are necessary in JavaScript applications, is required to contact the token endpoint. And implicit flow provides a convenient mechanism for JavaScript applications to obtain access token for a web API, offering numerous advantages in respect to cookies. Tokens can be reliably obtained without any need for cross-origin calls. Mandatory registration of the redirect URI to which tokens are returned guarantees that respect to cookies. Tokens can be reliably obtained without any need to cross-origin calls. Mandatory registration of the redirect URI to which tokens are returned guarantees that tokens are not displaced. So the JavaScript application can obtain as many as access token as they need for as many web APIs as they target with no restriction on domains. HTML5 features like session or local storage grant full control over token caching and lifetime management, whereas cookies management is opaque to the app. Access tokens aren't susceptible to cross-site request forgery (CSRF) attacks. The implicit grant flow does not issue refresh tokens, mostly for security reasons. A refresh token isn't a narrowly scoped as an access token, granting far more power, hence inflicting far more damage in the event that it is leaked. In the implicit flow, tokens are delivered in URL, hence the risk of interception is higher than in authorization grant flow. However, a JavaScript application has another mechanism at its disposal for renewing access tokens without repeatedly prompting the user for credentials. The application can use a hidden iframe to perform new token requests against the authorization endpoint on Azure AD. As long as the browser still has a session cookie against the Azure AD domain, the authentication request can still successfully occur without any need for user interaction. So if the user session is still valid, you can make a call in the background using the session and still make it still authorize it without the user. This model grants JavaScript applications the ability to independently renew access tokens and even acquire new ones for a new API, provided that the user previously consented for them. This avoids the added burden of acquiring, maintaining, and protecting a high-value artifact such as refresh token. The artifact that makes the silent renewal possible, the Azure AD session cookie is managed outside of the application. Another advantage of this approach is user can sign out from JavaScript application will automatically lose the ability to renew tokens for the signed out user. So there are two types of uh, grant flow: the authorization code grant and implement implicit grant. And we discussed what are the advantages and what are the disadvantages. It was really big discussion, but let's just point out a few things. For authorization code grant, the authorization endpoint used during the user interaction phase, the endpoint, the token endpoint used by a client to exchange the authorization code for an access token and optionally refresh tokens. Whereas implicit grant, it allows a client to obtain an access token and ID token when using OpenID Connect directly from the authorization endpoint without relying on token endpoint. It never returns a refresh token to the client. It is intended for JavaScript applications running in a browser such as SPAs. It should not be used for native clients, web applications that include a backend and consume an API from backend code. So it should not be used for native application clients and web applications that include a web backend and consume an API from the backend code. So implicit grant should not be used in those cases. Authorize access to Azure AD web applications by using OAuth 2.0 code grant flow. Registering an app with Azure AD tenants, as you describe the process of authorizing access to Azure AD web applications that use code grant flow. Authorization code flow begins with the application with the client directing the user to the authorized endpoint. In this request, the client indicates the it permissions needs to acquire from the user. You can get the OAuth 2.0 authorization endpoint for your tenant by selecting app registrations, by going to the app registrations and selecting the app and endpoints in Azure portal. At this point, user is asked to enter their credentials and consent to permission requested by app in the Azure portal. After the user authenticates and grants consent, user Azure AD sends a response to your app in the redirect URI address in your request with the code. So, so now you have acquired an authorization code and have been granted permission by the user. You can redeem the code for an access token to the desired resource by sending post request to the token endpoint. Azure AD returns an access token upon a successful response. To minimize network calls from the client application and their associated latency, the client application should cache access token for the token lifetime that is specified in the OAuth 2.0 response. To determine the token lifetime, user either can use either expires in or expires on parameter values. If the web API resource returns an invalid token error code, this might indicate that the resource has determined that the token is expired. If the client and resource clock times are different, known as time skew, the resource might consider the token to be expired before the token is cleared from the client cache. If this occurs, clear the token from the cache even if it's still within its calculated lifetime. Now that you successfully acquired access token, you can use the token to request web API by including it in the authorization header, and then access token are short-lived and must be refreshed after every expire to continue access resources. You can refresh the access token by submitting another post request to the token endpoint but this time providing refresh token instead of the code. Refresh tokens are valid for all resources that your client has already been granted access to. Then there is service to service call using client credentials. OAuth 2.0 client credentials grant flow permits a web service serving the role of confidential client to use its own credential instead of impersonating a user to authenticate even when calling another web service. In this scenario, a client is typically a middle tier web service, a daemon service, or a website. For a higher level of assurance, Azure AD also allows the calling service to use a certificate instead of a shared secret as a credential. In here, the first step, the client application authenticate to Azure AD token issuance endpoint and request an access token, and then the Azure AD token issuance endpoint issues the access token. Then the access token is used to authenticate the secured resource, and the data from the secured resource is returned to the client application. So this is service to service calls. Now, managed identity, another interesting topic. In this lesson, we will cover overview of managed identities for Azure resources, configuring managed identity for Azure resources on an Azure VM by using Azure CLI, the use of managed identity for Azure resources on an Azure VM to acquire access token, assigning access to managed identity to a resource by using Azure CLI. A lot to do. Let's go. Overview of managed identity for Azure resources. A common challenge when building cloud applications is how to manage the credentials in your code for authenticating to cloud services. Keeping the credentials secure is an important task. Ideally, the credentials never appear on developer workstations and aren't checked into source control. Azure Key Vault provides a way to securely store confidential or secrets and credentials and other keys, but your code has to authenticate to Key Vault to retrieve them. The managed identity for Azure resources feature in Azure Active Directory solves this problem. The feature provides Azure services with an automatically managed identity in Azure AD. You can use the identity to authenticate to any service that supports Azure AD authentication, including Key Vault, without any credentials in your code. The diagram here, current slide, which illustrates how a managed identity works with an Azure VM. Azure Resource Manager receives a request to enable the system assigned managed identity on a VM. Create a user assigned managed identity and assign it to the VM. Azure Resource Manager creates a service principal in Azure AD for the VM's identity. The service principal is created in the Azure AD tenants that trusted by the subscription. Then Azure Resource Manager configure the identity on VM, which means it updates the Azure instance metadata service identity endpoint with the service principal client ID and certificate. After the VM has an identity, use the service principal information to grant VM access to Azure Resource. To call Azure Resource Manager, use role-based access control in Azure AD to assign the appropriate role to the VM service principal. To call Key Vault, grant your code access to the specific secret or key in key control, key in Key Vault. Then your code that's running on VM can request a token from two endpoints that are accessible only from within the VM. Azure Instance Metadata Service Identity Endpoint, which is this one, can request, and then X6 is a call is made to Azure AD to request an access token as specified in X step 5. And then 7, your code sends the access token to a call to a service that supports Azure AD authentication. Configure managed identity for Azure resources on an Azure VM by using Azure CLI. So here you can use system assigned managed identity. Simply you just have to do it's using Azure CLI. So AZ login, AZ group, create my resource group, then location, simple AZ VM, create resource group, my resource group, and my VM image, this, you created the VM. And then AZ VM identity assign, you just say G my resource group, and then name of the VM is my VM. So simply you assigned system assigned managed identity to the VM using Azure CLI. Here we logged into Azure CLI, then created a group, and then created a VM, and then assigned system assigned manager identity to the VM. Configure managed identities for Azure resources on an Azure VM by using Azure CLI. So the same process, you log in. This is user assigned managed identity. This was system assigned managed identity. So here you log into the Azure portal, sorry, to Azure using Azure CLI, Azure group, create my resource group. Then you create an identity, which is simple. You create an identity on this resource group, my user assigned identity, and then you create the VM and then VM identity assigned. So you assign the identity to the VM which we previously created. And in this one, we simply assign the resource group identity, which is system assigned, and this is user assigned managed identity. How to use managed identities for Azure resources on an Azure VM to acquire an access token. Client application can request managed identities for Azure resources app only. Access token for accessing a given resource. The token is based on the managed identities for Azure resources service principle. As such, there is no need for the client to register itself to obtain an access token under its own service principle. The token is suitable for use as a bearer token in service to service calls, returning client credential. While the managed identities for Azure resources subsystem being used by managed identities, it does cache tokens. It is also recommended to implement token caching in your code. As a result, you should prepare for scenarios where the resource indicates that the token is expired. On the wire calls to Azure AD results only when cache miss occurs due to no token in the managed identity. The cache token is expired. So only two reasons. That's why you should consider token caching, error handling, and retry guidance. Assign a managed identity access to a resource by using Azure CLI. So assign a managed identity access to a resource by using Azure CLI. What we need to do? We are going to use to assign managed identity access to another resource role-based access control. So what we do, we log into Azure and then we resource list with my VM query and we query the identity principal ID and then we this principal ID with this name dev test VMSS and then we create a role assignment for this ID SPID and this SPID a role of reader with this subscription. Simple. Create a managed identity. I will demo. For the demo purpose, I'm creating a virtual machine and I entered basic information there. I don't want to take much time, but I want to highlight one thing. When you create virtual machine, if you want to create system assigned managed identity, then you can turn it on. I don't want to turn it on. So one way of doing it is here. So I just you can turn it on here and then you can have a system assigned managed identity. It's validated and now I can create my VM. And another way of doing or creating a system assigned managed identities, enabling system assigned managed identity, you have to go to your virtual machine, and then you can add it in identity. I'll show you in a while. And while you are creating virtual machine, you can only enable system assigned managed identity. And to add your user assigned managed identity, you have to go to your virtual machine and do it. So let's wait for this. It is taking some time. Everything is done. Okay, one only this is remaining. Okay, that is also done. Let's wait. It says done. And very interesting to know is, um, you user assigned identity, managed identity, you can assign it. To assign a user assigned managed identity, as I said, you have to go to your VM, and you need virtual machine contributor, or a virtual as a role. You need to have that role to make it possible. Okay, let's go to the resource now. Our virtual machine is ready, and here you see it's up and running. You can connect SSH, RDA, RDP, or Bastia, whatever. I'm not talking about it. I'm not going to do it because you can. I have another video which talk about Azure virtual machines and developing solutions that use Azure virtual machine. You can use that. But here I want to talk about identity. In identity, you have system assigned and user assigned. So if you have your existing virtual machine, and if you want to add managed identities to your virtual machine, you can add them here. So you can say on and save it. Yes. And then for Azure, as for user assigned, you can add, and you can say subscription, and then you can filter for user assigned managed identities here. But I haven't created any managed I haven't created any managed identity which I need to create for my application. So um, now what I'm doing here, I'm adding any existing identity to my application, which is possible. If I don't have any, I need to create. Let's say I have an web API which want to access my virtual machine. What I can do, I can create user assigned managed identity on that web API. So that will create an identity in Azure Active Directory which has access. If I add that identity here to my virtual machine using this portion, then that web API or that identity will have access to my virtual machine. Simple. So as we just saw how to create a managed identity in a portal, now implement certificate based authentication. In this, we will have an overview of certificate based authentication, legacy authentication methods, token based authentication. Certificate based authentication. Client certificate authentication enables each web-based client to establish its identity to a server by using a digital certificate which provides additional security for user authentication. Certificate-based authentication can be useful in scenarios where your organization has multiple front-end applications. Communication with backend service. Traditionally, the certificates are installed on each server and machines trust each other after validating certificates. This same traditional structure can be used for infrastructure in Azure. With cloud native applications, you can use certificates to help secure connections in hybrid scenarios. For example, you can restrict access to your Azure web app by enabling different types of authentication for it. One way to do so is authenticate by using a client certificate when the request is over TLS layer or SSL. The mechanism is called TLS mutual authentication or client certificate authentication. As another example, Azure API management allows more secure access to the backend service of an API using client certificates. So you can add one more layer of security using client certificates. In context of Microsoft Azure, certificate-based authentication enables you to be authenticated by Azure Active Directory with the client certificate on Windows or mobile device when connecting to services listed on the current slide. Where so if you want to get access to Microsoft SharePoint Online, Microsoft Office 365, Skype, Azure API, third-party services deployed in your organization. Legacy authentication methods, form-based authentications. So for many people, form-based authentication is still the case actually, because many people could not move on. But that is, sorry to break it to you, it's already legacy now. Most cloud native applications will use a token based or certificate based authentication scheme. However, many applications are migrated to the cloud or connected to the cloud in a hybrid way. These applications might already have significant developer investment that makes changing the authentication scheme a significant resource challenge. Form authentication uses this HTML form to send the user's credential to the server. It is not an internet standard. Form authentication is appropriate only for web APIs that are called from a web application so that user can interact with the HTML form. So it has significant disadvantages. Requires a web browser to use the HTML form, requires measures to prevent cross-site request forgery. User credentials are sent in plain text as part of HTTP requests, so anyone can look at them. So these are the legacy application, what it is in general life. So you say, okay, I want to access my home page. Then it says, oh, you are not authenticated yet, so it will redirect you to account.login to login, and then you say okay. It says okay, then you'll get uh, it will return authentication, and then uh, after that it will return to the home page. So it's just simply old method of doing things. Still many people are doing it actually, but it gives you many problems. Legacy authentication methods, Windows based authentication. In this, the hybrid development, it is common to see main responsibilities of identities moved from on-premises Active Directory to Azure Active Directory. The on-premises Active Directory server remains as a way to manage physical machines and to enable simple Windows-based authentication. Azure AD Connect is used to synchronize identity from Azure AD to an on-premise Active Directory server. So uh, enables users to log in with their Windows credentials by using Kerberos or NTLM, and then client sends credential to the authorization with the in the authorization header. but this also has many disadvantages. Difficult to use in internet applications without exposing the entire user directory. Can't be used in bring your own device scenarios. Requires Kerberos or integrated Windows authentication and TLM support in client browser or devices. The client must be joined to the Active Directory domain. Then token based authentication claims based authentication in .NET. Historically, ASP.NET applications used form authentication to solve member requirements that were common in early 2000s. These requirements mostly revolved around authoring login forms and managing a Microsoft SQL Server database for username and passwords and profile data. Today, there is much broader array of data storage options for web applications, and most developers want to enable their sites to use social identity providers for authentication and authorization functionalities. While it's possible to implement these new features in a database, it is unnecessarily difficult when many identity providers implement storage token and claims already. So ASP.NET Identity is a unified identity platform for ASP.NET applications that can be used across all types of ASP.NET and in web, phone, store, or hybrid applications. So it's simply claim-based authentication. It represents user's identity as a set of claims, and a provider model for logins facilitates adding, removing, or replacing identity providers. Token-based authentication, app service authentication, and authorization. Azure App Service provides built-in authentication and authorization support, so you can sign in user and access data by writing minimal or no code in your app instance. The authentication and authorization module runs in same sandbox as your application code when it is enabled. Every incoming HTTP request passes through it before being handled by your application code. So you can add to your Azure App Service directly authentication and authorization. It's built in and you don't have to write any code or very minimal code if you want to use the authenticated users data in your database, or if you in your application, then you need to write some code, but otherwise you don't need to write anything. You can easily enable the authentication of your app service easily by just selecting Azure Active Directory or other providers. Token based authentication, app service authentication and authorization in the same. All auth and auth logic, including cryptography for token validation and session management, executes in worker sandbox and outside of the your web app code. The module runs separately from your application code and is configured using app settings. So no software development kits, specific languages or changes to your application code are required. Identity information flow directly into your application code. For all language framework, app service makes the user claims available to your code by injecting them into request header for Microsoft.NET application app service populates claims principal.current with the authenticated user's claim. So you can follow the standard .NET code pattern, including the authorize attribute. Similarly for PHP apps, app service like a server remote user variable. So you can easily, so your app service is authenticated and then it inject a claims principal.current which has all the user specific information, and you can use that in your code to determine what you can use that in your code to do things with it. So that means you don't have to write any code or very minimal code. Implementing Azure multi-factor authentication. So here in this lesson we will learn more about what is multi-factor authentication, with Azure Active Directory. Single factor can potentially be compromised either intentionally or unintentionally. A badge can be stolen and used as by an unauthorized party. During a robbery, someone could ask you to use your fingerprint on a device, and a mobile company could accidentally send SMS messages to another device. So, to solve this problem, we have a multi-factor authentication mechanism. Any proof that you are who you claim to be is called factor. It includes a physical badge in your company, knowledge of your answers to security questions, a mobile device registered with the company that can receive notifications, phone call or SMS, physical appearance that can be captured by a camera device, fingerprint that could be captured by a biometric scanner. So you have a different type of multi-factor authentications. Further, it can be split into three things: knowledge, possession, inheritance. Knowledge, something that only the user knows, security questions, password or pin. Possession, something that only user has, that means corporate badge, mobile device or security token. Inherent, something that only user is, fingerprint, face, voice or IRS. The practice of using two or more factors when authenticating is referred to as multi-factor authentication. It is recommended to have a factor from two out of the three of the categories described above. Like if you choose knowledge and possession, you can choose possession and inheritance, whatever, but choose two of the three. You can have Azure multi-factor authentication with Azure Active Directory, which is MFA, is a two-step verification solution that built into Azure AD. Administrators can configure approved authentication methods to ensure that at least two factors are used while still keeping the sign-in process as streamlined as possible. So it can be enabled in two ways: enabled manually for each user by the account administrator, enabled automatically by using a conditional access policy that is triggered by risky login behavior. Risky login behavior is something like if you are logging in to your company portal outside of the company network. That means you are not inside the company network, and it will trigger automatically two-factor multi-factor authentication. It includes call to a phone, text message to phone, notification through the mobile app, verification code from the mobile app. And verification code from mobile app generates a new OAuth verification code every 30 seconds. The user enters the verification code and into sign-in interface. You can receive a call to your phone, you can get a text message to your phone, you can have a notification through mobile app. So you are logging into your desktop through a desktop, and you receive a notification to your mobile app. Review. So finally, in this video, we talked about Microsoft Identity Platform. We implemented OAuth 2.0 authentication, implemented managed identity, implemented certificate-based authentication, implemented Azure multi-factor authentication. I hope you understood it. This video was a little bit longer because it has many things and many things to talk about, and many interesting things actually, and very important part of your application development and Azure cloud application development. So I hope you liked it, and thank you for watching. Please like, share and subscribe. Until then, see you soon. If you want to continue to my applications, you can watch my playlist 203, AZ-203 or AZ-204. Thank you. Bye.